Welcome to this edition of Avaya Technology Sessions on the subject of designing and implementing a PCI DSS compliant network using Darkhorse networking services with Avaya's Fabric Connect. I'm Ed Kohler and I will be your host for this session. In recent decades, communication technologies have realized significant advancement. These technologies touch almost every part of our lives, sometimes in ways that we do not even realize. As this technology evolution has and continues to occur, many systems that have previously been treated as discrete are now networked. Examples of these systems are power grids, metro transit systems, water authorities, and many other public services. Other examples are networks that require regulatory compliance, such as PCI DSS and HIPPA. While this evolution has brought on a very large benefit to those both managing and using the services, there is the rising specter of security concern and the precedent of documented attacks on these systems. This has brought about strong concerns about this convergence and what it portends for the future. Avaya's Fabric Connect is an enhanced implementation of IEEE 802.1aq shortest path bridging. Fabric Connect can offer a series of circuit-based services that can be either Layer 2 or Layer 3, depending upon requirements. These circuits are constructs known as ICIDs, or I-Component Service Identifiers. If these services are used in the proper fashion, they can yield what are termed as Darkhorse networking services. A Darkhorse network is any network that is enclosed and self-contained with no reachability into and or out of it. It also must be mutable in both services and coverage characteristics. The common comparable terms are MPLS IPVPN and routed black hole networks. Avaya's Fabric Connect, based on IEEE 802.1aq, provides for fast and nimble private networking circuit-based capabilities that are unparalleled in the industry and do not require complex mixes of protocols or design practices. Hence, Darkhorse networks are private, dark networks that are provided as services within the Fabric Connect cloud. They come in two different forms: a Layer 2 Darkhorse, which is a non-IP routed Layer 2 VSN environment, and a Layer 3 Darkhorse, which is a true L3 VSN IPVPN environment. There are many uses for Darkhorse networks, but they basically fall into two category types. First, networks that require security and isolation. Examples are PCI and HIPPA compliance, financial and trading applications, video surveillance, and process flow control environments, such as those facilitated by SCADA-type protocols. Second are networks that require services separation, such as multiple multicast domains or multi-tenant situations. As an additional note, Darkhorse networks provide effectively for both environment categories. While this presentation is focused on PCI DSS, these services can be used for other closed service-separated networking requirements, such as those for HIPAA, which is in healthcare, and SIP NERC, which is in the National Regulatory Agency domain. The requirements for true PCI compliance are numerous and complex. As such, no networking technology or solution can be compliant to the regulation. In short, scanning of the actual implementation by qualified staff is required. There is, however, a lot one can do to prepare for this. First and foremost is securing the data path. Avaya's Fabric Connect contributes to these requirements by providing for strict control of the forwarding path behavior. Before we move on with PCI DSS, let's take a moment and talk about the differences between PCI DSS and PA DSS. PA DSS is the application security standard, which is as such a subset of PCI DSS. An important aspect of PA DSS is that it defines what a compliant application must support as it is designed. Areas of concern are the handling of magnetic stripe data, card verification codes, and also PINs. If a point-of-sale application is sold off the shelf, it must comply to this certification. If it is an in-house application, then it is the responsibility of the designing merchant or service provider to properly design and certify the application. In contrast, PCI DSS deals with the whole end-to-end implementation as it is deployed. As such, the end-to-end system must be scanned by properly trained and certified consultants to gain compliance. This is an important consideration because if the deployment is not properly thought out, compliance can become a moving target where any changes made to the deployment over time can put the compliance at risk. Fortunately, there is an approach referred to as sampling and the use of deployment templates, which can drastically ease both the attainment and ongoing maintenance of compliance. Avaya's Fabric Connect and the use of secure circuit-based services referred to as Darkhorse virtual service networks can also drastically ease the burden of developing and enforcing a templated PCI PSS design. Obviously, the major role that Fabric Connect's Darkhorse services provide is in the areas of services and path separation and control. All of this revolves around the next generation network segmentation abilities that Avaya's Fabric Connect provides. According to PCI DSS, while network segmentation is not explicitly required for compliance, its use is strongly recommended. The use of network segmentation can provide an effective foundation for sampling and templates. As such, it can be used to reduce the scope of the initial assessment and, as a result, its overall cost. Additionally, it can provide for significant reduction in the cost of ongoing maintenance for the environment. But this is only if the network segmentation is secure and properly designed and implemented. Proper design, however, can in turn lead to modularity and the ability to maintain consistency with the modules. The end result is the ability to streamline compliance by the use of these templates and sampling. Avaya's Fabric Connect architecture, which is based on an enhanced version of IEEE 802.1aq shortest path bridging, uses an advanced application control broker element known as identity engines. When used in tandem with Fabric Connect, Identity Engines becomes a very powerful PCI enforcement tool that can address the whole area of network segmentation as it is defined and addressed in Appendix D for PCI DSS compliance. Highlighted in red are the areas where IDE and Fabric Connect merge to provide a total enforcement paradigm for the PCI DSS network service paths. Its use also complements and simplifies PCI audit requirements. In an early blog article, I introduced the concept of composite identities and the fact that all identities in cyberspace are as such. This basic concept is rather obvious when it speaks to elemental constructs of device-user combinations, but it gets smeared and somewhat fuzzy when the concept extends to applications or services. Or it can extend further to elements such as locations or systems that a user is logged into. All of these are elements of a composite instance of a user as they exist on the network, and they are contained within a space-time context. As an example, I may allow user A for access to application A from location A with device A, but any other location, device, or even combination of time can provide a totally different authentication and consequent access approach, or perhaps even a complete denial of service. This composite approach is very powerful, particularly when combined with the rather strong path control capabilities of Avaya's Fabric Connect. This combination yields an ability to determine network placement based on user behavior patterns, those expected and within profile, but more importantly for those that are unusual and out of the normal user's profile. These instances may require additional challenges and consequent authentications. As noted in the slide, this series of gates concept merges well with this construct. The first gate provides the identification of a particular user-device combination. From this elemental composite, network access is provided according to a policy. From there, the user is limited to the particular paths that provide access to a normal profile. As the user goes to invoke certain secure applications or log on as a different user for secure applications, the network responds with additional challenges. This may be an additional password, or perhaps a certain secure token or biometric signature to assure the identity for added degrees of trust. All of this is normal. But in the normal enforcement environment, the access is provided at the system's level, thereby increasing the smear of the user's identity across the network. A critical difference in this approach is that we are referring to the whole network placement profile of the user changes. In other words, in the previous network profile, the system that provides the secure application is not even available by any viable network path. It is by the renewal of the challenge and additional tiers of authentication that such connectivity is granted. Note how I do not say access, but connectivity. Certainly, systems access controls would remain, but by and large, they would be the last and final gate for security. At the user edge, whole logical topology changes occur that place the user into a Darkhorse IPVPN environment, where secure access to the application can then be obtained. Let's take a moment and talk about the anatomy of these circuit-based services. The anatomy of a Layer 3 Darkhorse network is actually very simple. It's nothing more than an ISID, which is short for I-Component Service ID, basically a shortest path bridging circuit, that is associated with VRFs. The VLANs attached to the VRFs are given IP addresses. However, none of the IP subnets are reachable outside of the IPVPN environment. As such, a standalone Layer 3 IP internet is created where nothing can enter or exit. It is, in essence, invisible to the outside world. This service type is useful for any secure Layer 3 protocol or environment such as PCI DSS networks, but also useful to provide service separation of possible conflicting protocol environments, such as those in the case of multiple multicast domains. The anatomy of a Layer 2 Darkhorse network is also very simple. It is nothing more than an ISID that is associated with VLANs. The VLANs are not given IP addresses, however. As such, a standalone Layer 2 network is created where nothing can enter or exit. These are extremely useful to extend secure Layer 2 protocol environments such as SCADA. Layer 2 Darkhorse networks allow for the easy and secure distribution of such protocol environments. Additionally, IP can run inside the Layer 2 Darkhorse network, but it is a self-contained IP subnet that is not routed to the outside world. It is in essence invisible. As a result, it can be used for secure data center usage where IP reachability is not necessarily desirable. Finally, a comparable service in MPLS, known as Layer 2 VPLS, requires roughly 30 to 40 command lines of code to execute, whereas a Layer 2 Darkhorse network and Fabric Connect is in essence one simple command. These services can be used in tandem and in combination to yield a totally closed network topology. As shown in the slide, a Layer 3 VSN is used to extend out to the PCI compliant network to the far end point of sale applications. These PCI DSS application end systems will gain access to the PCI network via Identity Engine's authentication. The Layer 3 VSN is then extended up to the data center security demarcation point, where there is a single secure port into the perimeter's firewall IDS boundaries. On the other side of the demarcation, secure L2 VSNs provide for connectivity to data center services. The whole end-to-end design yields a closed system network environment that is totally isolated from the outside world. There is simply no way in and no way out. In this whole model, something significant occurs. Users are now in communities of interest where only certain traffic pattern profiles are to be expected. As a result, zero-day alerts of anomaly-based IDS/IPS systems become something other than white noise. They become very discrete resources with an expected monitoring profile, and any anomalies outside of that profile will flag as a true alert that should be investigated. This enables zero-day threat systems to work far more optimally, as their theory of operation is to look for patterns outside of the expected behaviors that are normally seen on the network. Fabric Connect complements this by keeping communities strictly separate when required. With a smaller isolated community, it is far easier to use such systems accurately. The slide illustrates the value of this virtualized security perimeter. Note how any other endpoint outside of the L3 VSN is logically on the outer network connectivity side. Even though ISIDs traverse a common network footprint, they are ships in the night in that they never see one another or have the opportunity to intercommunicate except by formal monitored means. Firewalls are also notoriously complex when they are used for community separation or multi-tenant applications. The reason for this is all of the separation is dependent upon the security policy databases and how well it covers a given application and port call. If a new application is introduced and it needs to be isolated, the security policy database must be modified to reflect it. If this gets missed or the settings are not correct, the application is not truly isolated and no longer secure. Again, Avaya's Fabric Connect and Darkhorse networking help in controlling users' paths and keeping communities separate. Now the firewall security policy database can be whitelisted with a blacklist deny all policy after that. Now, as new applications get added, unless they are added to the whitelist, they will be isolated by default within the community that they reside in. There is far less manipulation of the individual security policy databases and far less risk of an attack surface developing in the security perimeter due to a missed policy statement. As mentioned, areas where Darkhorse network topologies are useful are in networks that require full privacy, such as PCI or HIPPA compliance. L3 virtual service networks are perfect for these types of applications or solution requirements. This slide could easily be an illustration for a PCI-compliant environment in which all subsystems are within a totally enclosed L3 VSN IPN environment. The only ingress and egress are through a well-defined security virtual perimeter that allows for the full monitoring of all allowed traffic. This combination yields an environment, when properly designed, that will easily pass PCI compliancy and scanning analysis. In addition, these resilient networks are not only private, they are invisible to external would-be attackers. The attack surface is mitigated to the virtual security perimeter only. As such, it is practically non-existent. As noted earlier, the use of sampling can greatly reduce the cost and complexity of attaining and maintaining compliance. The practice does, however, require discipline in both the modularity and consistency of the design and implementation. Modules can then in turn be templated and reproduced, but this must be done exactly as defined within the template. Variations will result in the need for scanning. Beware, small, seemingly inconsequential divergences from templates can result in the need to scan a particular module. As an example, a remote point-of-sale location where suddenly a new operating system is used, or in the case of a data center where a particular data repository is migrated to a different SAN or non-SAN technology. But if it is done properly, sampling and templates can drastically reduce the overall compliance and ongoing maintenance costs. This is Appendix D of the PCI DSS version 2 documentation. As shown, if the requirements for network segmentation are both realized and validated, then the whole process effectively moves on to the sampling of business facilities, system components, and practices. Avaya's Fabric Connect can address all of the network segmentation requirements without the need for undue complexity, such as those introduced by technologies such as MPLS. This slide shows a higher-level view of the modularity and sampling concept. By dictating module demarcation points and implementing the modules exactly as defined within the templates, compliancy can be streamlined. As an example, for a remote point-of-sale location, if a series of templates were created, such as small, medium, and large, and those templates covered all hardware, network topologies, and configurations, and those templates were then adhered to, then, at the time of compliance scanning, only one of each site type needs to be fully scanned. Network topology documentation, configurations, and such can be used as due equivalents for all other sites of that type. If an organization is dealing with a large number of point-of-sale locations, This approach can have significant impact on the overall cost and difficulty of attaining and maintaining compliance. From Avaya's Fabric Connect perspective, it's all about services separation and path control, or network segmentation, as referred to in PCI DSS documentation. No other networking technology provides a more comprehensive set of services with so little complexity. As a result, the checklist is fairly easy. Be sure to terminate L3 VSNs as close as possible to the edge. Avoid using shared broadcast domains or VLAN extensions via tag trunks. If VLAN extensions are required, use L2 VSNs to maintain total separation. Limit port memberships into the security demarcations only to those required. Ideally, this should be a single port membership to prevent unauthorized system access to the DMZ. Limit port memberships only to the PCI DSS endpoints. Identity engines can greatly ease the enforcement of these access policies. Avoid mixing any non-PCI DSS applications in the PCI DSS Darkhorse topology, even if they do not access anything else outside of that network. As such, mixing can result in the violation of templates and hence require full site scanning. Validate the security demarcation module and create a defined security policy database and network topology template. Be sure to do testing of the demarcation to be sure that the policy database is enforced. Finally, avoid the use of public internet or wireless services within the end-to-end design whenever possible. When this cannot be avoided, use encryption to protect transit data. MACsec encryption can be used to protect exposed Ethernet trunks, and full VPN encryption can be used with IPsec or SSL to provide end-to-end or even branch site connectivity. Be sure to have IPVPN gateway attached directly to the Darkhorse network topology to ensure that there are no exposed unencrypted data service paths. While private IPVPN environments have been around for years, they are typically clumsy and difficult to provision. This is particularly true for environments where quick dynamic changes are required. As an example, the typical MPLS IPVPN provisioning instance will require approximately 200 to 250 command lines, depending on the vendor and the topology. Interestingly, much of this CLI activity is not in provisioning MPLS, but in provisioning other supporting protocols such as IGPs and BGP. Also consider that all of this is just for the initial service path. Any redundant service paths must then be manually configured. Compare with Avaya's Fabric Connect, which can provide the same service type with as little as a dozen commands. Additionally, there is no requirement to engineer and provision redundant service paths, as they are already provided by Avaya's Intelligent Fabric. As a result, IPVPNs can be provisioned in minutes and be very dynamically moved or extended according to requirements. As an example, an article on the evolution of E911 speaks to how an L3 VSN IPVPN can morph over the duration of a given emergency, with different agencies and individuals coming into and out of the IPVPN environment on a fairly dynamic basis based on their identity, role, and group associations. Furthermore, SPV nodes themselves are mutable. Once again, ISIS provides for this feature. A Fabric Connect node can unplug from the network and move to the opposite end of the network topology, which can be hundreds or even thousands of kilometers away. There, they can plug back in, and ISIS will communicate the nodal topology information as well as all provisioned services on the node. The SPV network will in turn extend those services out to the node, thereby giving complete portability to that node as well as its resident services. In addition, SPV Fabric Connect can provide for the separation of non-IPVPN environments as well. Protocols such as SCADA can enjoy an isolated non-IP environment by the use of L2 VSNs without IP addresses. And further, they can be isolated so that there is simply no viable path into the environment for would-be attackers. This combination of privacy, fast mutability of both services, and topology lend to what are termed as Darkhorse network services. They are dark, so they cannot be seen or attacked due to the lack of attack surface for such an endeavor. They are swift in the way they can morph by service extensions, and they are extremely mobile, thereby providing for the ability for nodes to make whole-scale changes to the topology and still be able to connect to the relevant provision services without any need to reconfigure. Any other IPVPN technology would be very hard-pressed to make such claims, if indeed they can make them at all. Avaya's Fabric Connect, based on IEEE 802.1AQ, sets the foundation for the true private cloud. With it, PCI DSS compliance becomes a breeze. Thanks for your time. For more details on Darkhorse networking technology, feel free to visit my blog site listed on the slide below. The latest article speaks to their use in metro and transit authority space, and the previous article speaks to their use in the evolution of next-generation 911 emergency response infrastructures. Thanks for your time.